Elon Musk, a space enthusiast, wants to use additive manufacturing or 3D printing technology to scale up the manufacture of SpaceX's rocket engines. His major objective is to automate the manufacturing process. In 2014, SpaceX used 3D printed components in its Dragon 3 aircraft for the first time. For the past 3 years, Elon and his team have been working to make this technology perfect. The 3D printing method is not only cost effective, but it is also extremely accurate. So, in today's video, we're going to discuss inside the genius 3D printer that makes SpaceX rockets. Let's roll in. 3D printing is one of Elon Musk's numerous accomplishments in his massive list of remarkable creations. Selective laser sintering is the key process that goes into it. Typically, 3D printers print continuously in a specific region until a three-dimensional figure is completed. They are given a computer-generated 2D render design to which they must map to material. SpaceX employs a proprietary high-performance superalloy for its rocket components, which is manufactured utilizing direct metal laser centering, or DMLS. They use 3D printing to make their emergency escape rockets first. The Dragon 3.0, SpaceX's initial entry-level use case, was primarily designed to compete with NASA, which had been working on something comparable for a long time. It was used to transport humans between the International Space Station and Earth. Do you want to know what Musk's statement said about this process? Well, here's what he said. "We are currently intending to build the pieces of our Merlin engine utilizing a high-end metal 3D printer and a leap motion controller that will be operated via the Oculus Rift VR headset." On January 5th, 2014, they utilized a 3D printed rocket engine's primary oxidizer valve, which flew alongside a SpaceX rocket. This rocket was carrying a payload of THACOM 5 telecommunications satellites into orbit. The valve was used in one of the Merlin 1D engines on the rocket. With the support of high-pressure liquid oxygen, cryogenic temperatures, and extreme vibrations, the valve operated admirably. Unlike its predecessor, which was handcrafted and took almost 2 weeks to complete, this valve required only 2 days to complete. This valve is now a proprietary element in all Falcon 9 flights. To keep up with SpaceX, NASA launched a 3D printer to the ISS from the California-based startup Made in Space. Many other European agencies have used 3D elements to construct lunar bases as well. This works by first sending a 3D printer to a moon or a planet where we wish to establish a base. SpaceX also employs 3D printing for its Super Draco thruster engine, which is an improved version of the Dragon's aircraft existing engine. Super Draco was used in airplanes that had to stay in orbit and in the Dragon 2 spacecraft. Typically, these engines are utilized to provide power to the escape systems of the vehicles. Now, this rocket has become totally reliable. Here comes the most interesting information which you would love to watch related to 3D printing. Let's keep watching the video. 3D printing was also used to create the helmet that fits on top of the custom-made Tesla astronaut outfit. Microphones, integrated oxygen chambers, and visor attraction and locking mechanisms are included in the helmets. SpaceX also intends to use additive manufacturing to produce the majority of the crew's equipment. When fully operational, the Super Draco engine can generate 6,000 pounds of thrust. SpaceX also put the Super Draco through a number of tests, including repeated starts, longer firing duration, significant off-nominal propellant flow, and temperature tests. The 8 engines within SpaceX's Dragon version 2 could generate over 120,000 pounds of axial force in the event that a spaceship needs to be moved forward in an emergency. It is impossible to overestimate the significance of this for the commercial space companies like SpaceX. The cost of building a rocket is high. As the RUD garbage heap develops in size, investors' judgments may become increasingly unstable. When firms vying to carry payloads into space have to postpone their launch dates owing to malfunctioning rockets, their public image suffers. Almost all new rocket companies and space entrepreneurs employ three-dimensional metal printing technologies. It speeds up their growth, helping them get through the crucial years before they can launch anything into space. With no indications of slowing down and an emphasis on scalability and cost reduction, 3D printing technology, both on Earth and in space, may become an increasingly important part of SpaceX engineering. SpaceX's key 3D printer supplier revealed that the company had begun utilizing its machines for a specific component that they had had substantial difficulty fabricating using previous methods. The business also stated that several components of the next generation engines for SpaceX's Starship cruiser to Mars were difficult to manufacture, and that as a result, the company changed to Velo 3D technologies over time. Many of the other organizations have used 3D elements to construct lunar bases as well. This works by first sending a 3D printer to a moon or planet where we wish to establish a base. The printer we supply should then be designed to create a larger printer printer capable of assembling minor components for a lunar outpost. This will also save money because you won't have to make as many trips to obtain raw materials. This is extremely helpful in bridging the gap between building a colony on Mars and the uncertainties that were holding humanity back. SpaceX also employs 3D printing for its Super Draco thruster engine, which is an improved version of the Dragon aircraft's existing engine. Are you enjoying watching this video? Keep watching until the end as we will discuss more interesting information related to SpaceX and 3D printing. Let's continue. SpaceX worked hard to develop lightweight, practical, and stylish spacesuits for the astronauts to wear today, in keeping with their company's avant-garde and futuristic approach, and because it anticipates its Demo 2 mission to become a historical launch event. According to the agency, the spacesuits are custom made for each person on board Crew Dragon to protect them from any depressurization. Because a question might be roaming around your mind: when did SpaceX come up with this 3D printing technique? Well, SpaceX was founded by Elon Musk in 2002. His goal was to lower the expense of space travel so that mankind might populate Mars in the future. This would be accomplished, according to SpaceX, by using completely reusable launch vehicles that would be the most powerful ever built, capable of delivering humans to Mars and other destinations across the solar system. Early in 2014, SpaceX launched its first 3D printed component into orbit. The part, a rocket engine main oxidizer valve, traveled on board SpaceX's Falcon 9 rocket, delivering the commercial Thycom 6 telecommunications satellite to orbit in January 6. Astronauts were also able to accurately land on safety thanks to the launch escape system, which was powered by 3D components. Overall, 3D printing allows the creation of cutting-edge components at a fraction of the cost of traditional manufacturing processes, and the outcomes have been excellent. Concerning SpaceX, if you don't know the history of Tesla, you can't genuinely call yourself an Elon Musk fan. What began as a consequence of lack of assistance from other parties when it came to supplying rockets has now evolved into one of the world's top space organizations. Though additive manufacturing of parts is currently prohibitively expensive for automobiles, it can quickly produce tooling to speed up the pace of innovation. It already makes sense for rocket engine components. To the best of our knowledge, SpaceX is 2 or 3 years ahead of the competition when it comes to additive manufacturing. Although 3D printers have been around for almost 7 years, the technology still needs more refinement and more intelligent AI cores to handle data. With its Falcon 9 rockets, SpaceX currently employs 3D printed components like the Super Draco and engine valves on a regular basis. It's unknown if SpaceX will be able to create a full-fledged rocket utilizing only 3D printing and all of its components. However, it is clear that this is a proper path for the industry, whose lightweight and complicated in-house production will have an impact on rocket payload limits. With that being said, this video has come to an end. Let us know in the comments, how do you see the future of 3D printers in the manufacturing of SpaceX rockets? I hope you enjoy watching this informative video. Make sure you hit that like, share, and subscribe icons below. This is it for today's video. See you guys in the next cool, mind-blowing video just like this one.